The dangers and challenges of space travel. Space travel is the final frontier, but it's also a realm filled with danger and uncertainty. From the threat of micrometeoroids to the challenges of long-term space travel, we'll take an in-depth look at the obstacles facing humanity's exploration of the stars. Don't miss out. Watch the video now and discover the dangers and challenges of space travel. Space technology cannot be agreed upon inside national borders and may have an impact on planetary assets or territory. As a result, domestic regulations must take into account international regulatory framework rules and regulations in order to prevent issues such as propulsion systems and technical challenges. Propulsion systems are essential for space travel as they provide the means to move a spacecraft through the vast expanse of space. The most common propulsion systems used in space travel are chemical propulsion, which uses the combustion of fuel to generate thrust, and ion propulsion, which uses electrical energy to accelerate ions to create thrust. Both of these propulsion systems have their own set of technical challenges that must be overcome in order for successful space travel to occur. One of the main technical challenges of chemical propulsion is the need to carry large amounts of fuel, which can be heavy and take up valuable space on the spacecraft. Additionally, chemical propulsion systems are not as efficient as other forms of propulsion, which can limit the amount of time a spacecraft can spend in space. Protection of humans. Space travel is an exciting and ambitious endeavor, but it also comes with significant risks and challenges. One of the most important considerations is the protection of human life. As we venture deeper into space, we must ensure that astronauts are equipped with the necessary tools and technology to survive the harsh conditions of the outer atmosphere. This includes designing spacecraft that can withstand extreme temperatures, radiation, and other hazards. Additionally, we must also consider the psychological effects of being in space for extended periods of time, such as isolation and confinement. Ensuring the safety and well-being of astronauts is crucial for the success of space travel and the exploration of our solar system. Earth environment. Space travel is a fascinating and exciting endeavor, but it also poses significant challenges to our planet's environment. One of the biggest concerns is the amount of debris and pollution generated by launches and re-entries. This debris can damage our atmosphere and potentially harm wildlife and ecosystems. Additionally, long-duration missions to other planets or moons can potentially introduce foreign organisms and contaminate these environments. Furthermore, the use of rockets and spacecrafts requires large amounts of energy and resources, which can contribute to climate change and deplete our planet's resources. To mitigate these challenges, scientists and engineers are continually developing new technologies and strategies to minimize the environmental impact of space travel. Low-cost space technologies. Low-cost space technologies have revolutionized the way we think about space travel, making it more accessible and affordable than ever before. However, despite these advancements, there are still many challenges that must be overcome in order to make space travel a reality for all. One of the biggest challenges is the high cost of developing and launching spacecraft, which can be prohibitively expensive for many organizations and countries. Additionally, the harsh conditions of space can make it difficult to design and build spacecraft that are capable of surviving the journey. Despite these challenges, many scientists and engineers are working tirelessly to develop new technologies that can help to overcome these obstacles and make space travel a reality for all. From reusable rockets to lightweight materials, the future of space travel is looking bright. The dangers of the space technology. The dangers of the space technology. Radiation. The first hazard of a human mission to Mars is also the most difficult to visualize because, well, space radiation is invisible to the human eye. Radiation is not only stealthy, but considered one of the most menacing of the 5 hazards. Above Earth's natural protection, radiation exposure increases cancer risk, damages the central nervous system, can alter cognitive function, reduce motor function, and prompt behavioral changes. To learn what can happen above low Earth orbit, NASA studies how radiation affects biological samples using a ground-based research laboratory. Isolation and confinement. Behavioral issues among groups of people crammed in a small space over a long period of time, no matter how well trained they are inevitable. Crews will be carefully chosen, trained, and supported to ensure they can work effectively as a team for months or years in space. On Earth, we have the luxury of picking up our cell phones and instantly being connected with nearly everything and everyone around us. On a trip to Mars, astronauts will be more isolated and confined than we can imagine. Sleep loss, circadian desynchronization, and work overload compound this issue and may lead to performance decrements, adverse health outcomes, and compromised mission objectives. Distance from Earth. The third and perhaps most apparent hazard is, quite simply, the distance. Mars is, on average, 140 million miles from Earth. Rather than a 3-day lunar trip, astronauts would be leaving our planet for roughly 3 years. While International Space Station expeditions serve as a rough foundation for the expected impact on planning logistics for such a trip, the data isn't always comparable. If a medical event or emergency happens on the station, the crew can return home within hours. Additionally, cargo vehicles continually resupply the crews with fresh food, medical equipment, and other resources. Once you burn your engines for Mars, there is no turning back and no resupply. Gravity, or lack thereof. The variance of gravity that astronauts will encounter is the fourth hazard of a human mission. On Mars, astronauts would need to live and work in 3/8 of Earth's gravitational pull for up to 2 years. Additionally, on the 6-month trek between the planets, explorers will experience total weightlessness. Besides Mars and deep space, there is a third gravity field that must be considered. When astronauts finally return home, they will need to readapt many of the systems in their bodies to Earth's gravity. Bones, muscles, cardiovascular system have all been impacted by years without standard gravity. To further complicate the problem, when astronauts transition from one gravity field to another, it's usually quite an intense experience. Blasting off from the surface of a planet, or a hurtling descent through an atmosphere is many times the force of gravity. Subscribe to Spacefight for more space videos. Thanks for watching.